Good morning. Happy Friday. How's everyone doing? Interesting. Page size is not needed. Why is that? Why would it be needed? I'm just cleaning up some warnings real quick before hopping in. Use DB info. Fine. All because page size. I probably should have looked at what were we removing this from here? DB info. Stream database updates. Stream database. Write DB transaction. Oh, okay. A database transaction. A vector of pages. We have a commit record. We're validating the checksum. Yeah, we just use the length of the page as the page size. I remember doing this. I think that's okay because we check the correctness of the data before we use it. Fine. So we do not need this anymore. Let's return unit. Attempt database download. Yeah, why are we returning that? Okay. Wow. We do this twice. That's right. That's right. We attempt the database download twice before restarting the process. If we get a none, it's not possible anymore. So it's OK unit or error. Mismatch types. Yeah, we'll get to that. Okay, none. We don't need that. Unit. So we convert that error into an OK. Got it. Mismatched types. Let's adjust the signature of this method. Too far. Okay. You know, I was thinking last night, I was trying to fall asleep, and I was trying to imagine what the keys on the keyboard were, and I couldn't. I just, I just know them. Like I don't look at my keyboard, right? And it was somewhat disturbing. Is that the Cascadia font? You know, I think it is whatever the default is for Ghost TTY. It's either that or what Helix uses by default. And good morning, Voidalgo. How are you? Hmm. Yeah, I'm happy it's Friday. I have some new end mills coming today. I'm hoping to play with this weekend. Yeah, I'm just surprised. I don't see it in here. So if it's not in Helix, then it's going to be the default font for Ghost TTY. I wonder how somebody says that. Is it Ghost T? Ghost TY? Ghosty? Hmm. I suspect it's the font chosen here, but I'm not really sure. All right, so this is just unit now. Hmm. Continue is never used. Bye-bye. Oh, there it is. It's used right there. Oh, because, wait, is that because it's used in our test code? Wow, this is kind of a sad song. Yeah. Okay, so let's check everything. I think the tests are all working. Let's make sure. While I choose on that, well, let's pull up the architecture diagram and figure out what's next. So we have an implementation of data archive. Oh, I figured it out. But this is our architecture. We have our stack. We host applications. The proxy directs read and write requests to different machines. Data changed on the writer is sent to data archive, which is replicated to the reader. All right. I want to double check that the consumers of data, for data archive know when to stop listening for their streams. Right. So our recent change revealed this. Data proto archive. Okay. So when we return a stream of something, the server, when it pushes data into the stream, if it closes the stream right away, the client won't get it because that pipe, that channel is done. As soon as the server drops it, it's done. So the server has to wait for the consumer to acknowledge that it received it or for the consumer to drop the connection. And because we control both, I say that the consumer just knows when to drop it. Hey, Miguel. How you doing? JetBrains Mono. Fascinating. I liked, let's see, I liked using Fira code, F-I-R-A. But I do admit I didn't notice the difference when I switched to Ghost GTY. Wonder. Settings. Yeah, I have nothing in my config. Hmm. Oh, we received a failure. Test database stream after database download. Hmm. Interesting. And one seems to be hanging. Oh, looks like that's where we're going. It's probably in line with this as well. So when we have a a stream of data, the client needs to know when to stop listening. So usually, at least for, let's see, database transaction just goes on forever. Database status goes on forever. But the fetch database response, you need to fetch data until you get all of the pages you need in a change. I think that's not quite correct at the moment, because the client doesn't know how long it must hold on, because it doesn't know how many pages mutated between the start DB checksum and the end DB checksum. In the response, we do not have a set of data that, like a point where it could check to see, have I reached the end? For database transactions, we know it's the end of a transaction because we have a commit record. Fetch database, stream database, where to go? Here. Is that the same as this one and this one? We have fetch database page and database page. Number, data, and checksum. Wow, look at that. Yeah. So I suspect that for the return type, right, I was just considering combining these two. I don't think that's a wise idea. I think we need to know the number of pages that are going to be downloaded, even if we had to send that on every message. So fetch database request, would it know how many pages changed? Ah, no, but it knows what the end database checksum has to be. So it just keeps applying pages until it gets enough pages to reach the end DB checksum. But what if there was an error? The page data checksum should have caught that. I'm trying to convince myself that using the end DB checksum and applying the patches to a database until you reach that point is a good enough metric to know when to stop listening for data. I think it is. Okay. If that's the case, we could reduce these. Hmm. Let's change that to database page. Fetch database response. Goes away. And we simply remove a page underscore from a number of places. Cannot find that. Is something else using that? No. Oh, is this in lib? Oh, it is. I was converting between the two. Okay, that goes away. What else? Close that. Lots of imports that don't exist. There we go. No, the some of the other values are just wrong. It's okay. We'll get there soon. These, yeah, these pieces. Let's see. So while I'm doing this, anybody have some fun weekend plans? Oh, continue your journey on learning Rust. and database management systems. Hmm. Sounds like a worthwhile cause. This one I don't like. See, this here, page number, page checksum, fetch page data. I guess I can't really get around that. Okay, I'll leave it. Where do we get page size here? We're passing it in. Okay, I'm gonna leave it. There we go. There we go. So we've combined those. Hopefully we do not have to split them. All right, let's fix some test. Test database stream after database download. I'm just wondering why it showed up twice here. Come on back. So why is this failing? Not much information here. Or am I just not seeing it? This is the compilation step. Okay, 2 tests in data plane that are failing. One, test DB sync if there are changes. This one, I'm gonna pour some tea while waiting on that. Wait, why did that? Okay, so there's a timing issue. Looks like it passed here. Hmm. If we run it over and over again, will we get to the point where we can reproduce the failure while running just these tests? Or do we need the other tests running at the same time? Yes. Interesting. Oh, wait, it did fail. Ah, look at that. Okay. Now, it seems a little odd. It's saying that it failed, but it's not saying why. Yeah, there's a lot of logging. A lot of logging for this. Okay. But where is it failing? Failed. Ah, here we go. There were page differences. Yes, okay. So what's going on? Test context with downloaded database. Okay, so we have a database that's downloaded from the server already. That's our test context. Then we check that a call to stream database updates happens. This is the request that's being made. Validate the request, and then the stream. What do we do with the stream? We send. So in this case, we are testing that the client works by puppeteering a fake server. So in this case, this is the stream that the server will send data to the client on. Oh, the tea is hot. Okay. So we send a response saying, here's a stream. We will just send you lots of data on this stream. So this DB transaction stream. Data! How's it going, Togglebit? And welcome, everybody. Happy Friday, man. Doing well. Looking forward to the weekend, you know. It's been good. Good week. Oh, Togglebit is definitely a recommended channel. A voice is so fancy. Oh, well, thank you. I mean, he's got the looks, right? I think together we might be like perfect for TV. I'll just do his voiceover. Although I really like Togglebit's voice. You don't have the goats, that's right. I'm actually looking to get rid of my last goat today. To a friend. Oh. Yeah, we did. We raised goats for a while. You know, between streams. I got a face for radio. I don't know. I've got a beard for TV and a face for radio. I don't. I just figure it's not what the stream's about. You know, I could toss on the purple lighting in the background and set up some candles, some romantic music, and I don't know, just. But that's not really my thing. That and I just don't like to wear anything low cut, you know? So I figure I'm content being just a streamer that streams coding. I don't need a billion followers, and that's okay. How you doing, Scott? Smiling big? And welcome. Here, let me show you what we're doing today. Then I would have to change the tag on my stream. I don't even know what the tag on my stream is. And I set that, what, 4 years ago? Right here. Well, let's pull up MonoDraw. This is where I do my architectural diagrams. Here we go. So, we've had multiple revisions of the architecture. Good morning. Morning, Mars. And with our architecture, this is, imagine some system like Fly.io with LightFS, right? I think that's kind of the closest analog. We end up having our own proxy. The proxy separates the safe requests, the reads, from the unsafe requests, the writes. The writes go into a specific machine where an application is hosted. That application uses SQLite to write to a database. The application also loads up our plugin into SQLite. The data that's mutated goes into our system here, data plane, where we have our data archive. Data archive replicates the data to all of the readers that apply the data to their databases. That's the kind of high level view of this. And then of course, if the writer blows up, then something else becomes the writer. Oh yeah, I still have all that code, Miguel. Miguel Murca, software and game development. I was working on an MMORPG. I called it legacy with the SEA, kind of a little play on words. So at the moment, we are looking at tonic, right? This is all Rust-based stuff. We have some protobuf code being generated. This is basically, we have a server that implements this interface. And at the moment, we are looking at a bit of test code that is failing. The test title is test database stream after database download. So the client goes through a number of requests, right? It gets the number of databases. Imagine a reader. Imagine a world where the reader is brand new. It has no databases. It makes a request to get the databases, the list of databases. And then one at a time, it starts to get information about a database. We delay fetching the info about a database because it can get stale. You thought I was going to say SCA for Society of Creative Anachronisms? No, not today. So we delay some of the information. And this has to do with checksum information because it can get stale. Let's say you were downloading a database that was multiple gigabytes. Maybe the other databases are updating rather frequently. We would want to get the information about them, the checksum, in order to fetch them at a specific point in time. Have to transfer less data. So we get told that a database exists. We fetch information about a database. Then we fetch the database itself. And then we stream updates about the database. Cyanic Penguin. Thank you for the follow. So it appears as though the test is failing as we start to stream the database updates. It's saying that there were differences. Problem happens to be that I noticed that I was not using a multi-threaded test runner, and I really needed to be using a multi-threaded test runner for this. So when I turned that on, tests started to fail. So it's all good though. All good. Let's take a look at the test. Lots of info there. Now the test is finicky. If I run it over and over again, it doesn't always fail. Although we got 2 failures in a row. All right. 3, 4. I'm liking the odds on this. All right. It is failing consistently. So here's our test. We start with the context. The database has already been downloaded. We assert, because we are puppeteering a fake server, we assert that the database, excuse me, that the client makes a request to stream database updates. We get the request, validate that it's correct, right? Because we are puppeteering a server, a very shallow server that's run by the test code. So we get a request back and a stream. validate that the request to the server was correct, and then we start to stream data to it. We drop the transaction stream, which I don't think we should be doing. I think this is where the problem is, because the client has not finished downloading yet. Essentially, we need to wait for the reader to drop the connection. The server shouldn't drop it until then. That should be stream dot closed. Gotta wait. Does this return an error? No. Okay. I cannot. Oh, it was moved. We could clone it. Send moves it. Oh, it consumes self. Was this a one shot? I'm looking at the wrong thing. It should have been this one that we wait for. So we send our transaction and we wait for the client to close the connection. The client needs to get all of the data, and I believe this is what the problem was. The database pages were not identical because the client didn't get them all. It didn't die. All right. Oh, this is good. Ah, but why does it linger? Hmm. Let's add a little logging. With some emotion. I'm getting some new end mills today for my CNC machine. Really looking forward to playing with them. I think the smallest one. Let's see. Oh, look. Okay. I think the smallest end mill is going to be, what, 64th or 32nd of an inch? Let me double check that. Just real quick. I have to satisfy this curiosity. Otherwise, it's going to be in the back of my mind for the rest of the stream. Oh, yes. 0.0312. Yeah, 32nd of an inch. Okay. I mean, I'm looking forward to that. But we did not get our information. I think it's here where the client never closes the transaction. That's the bug. So if the client is never closing this transaction or this stream, why is it not closing it? Ah, yes, we have but no b. Okay. Let's take a look at the client. Stream database updates. So what's going on here? We decide, oh, after downloading the databases and whatnot, right? We have a connection to the server. We know what the path to the database is, the starting checksum, and whether or not we should spawn a task for reasons. Now, we open the file. We ask for the updates. And then we iterate over the list of updates forever. Okay, point is here that the client isn't actually supposed to stop listening. Oh, that's right. The client should never stop listening for database updates. So how do we ensure that for our tests, we can get to a stopping point? Because the client isn't going to close the channel. We could shut down the system. What else could we do? We have to be careful, though. Oh, not that file. Because it might skip right to this point. So we need to ensure that it receives this. We could inspect the file itself, saying, hey, are we there yet? Are we there yet? What else? What else could we change? Because the side effects should be that the client changes the database on disk. So we just iterate, waiting for it to be correct. Because there are a number of pages in a transaction that must be written. Yeah, I don't think we should shut down. That would create a flaky test. So we might not hit the first case. Verticam, thank you for the follow. This is a tricky one. We send the transaction, and there's no way to know how much data is in the stream. At least I don't think there is. Where's Tokyo? Tokyo here. Unbounded sender. There's close. We were trying to look at that. We can send. Not so useful. Strong count. It's going to stay open. I don't think there's other helpful traits. Permit iterator. Interesting struct. Okay. Returns the number of weak unbounded sender handles. I don't think having a weak sender, weak unbounded sender is going to be useful. Yeah, I think we're kind of left with checking the file on disk. Just thinking through it, I'm not seeing another way. Unless we instrument the client to emit some sort of event, which isn't bad. Maybe we could look at some sort of like a metric or eventing. I kind of like that idea. I like the test to be predictable, right? Precise. I don't like the idea of checksumming a file over and over and over again until it matches what we expect. How do you know when to stop? Okay. Let's look at our test client, or excuse me, at our client. Is it database sync? I believe it is. Database sync, shutdown, join handles, yes, and checksum DB. I think that is it. Yep. Okay. I would like this thing to emit events. That way we could tell, right? We could collect these events later in production to have graphs, see how many pages are changing per machine. Maybe that would give us an idea of when a machine is getting close to its limit. I do like that idea. And for testing, we can just see when a specific event happens. Okay. What do we call that though? Stats? No. These would be events for that I would hope get pushed into our open telemetry. Maybe we call it telemetry. Hmm. Telemetry metrics, telemetry events. I kind of like it. Okay. This would be a sender, right? We would want a sender. Now, does Tokyo doesn't have an like a MPMC, does it? MPSC, one shot broad. It has broadcast. Hmm. Yeah, if you want to produce for many consumers, we could use that. Yeah, the watch channel. No, I don't care about that. Maybe broadcast. Although I expect there only to be a single consumer. All right. Let's try to use an MPSC channel. Now, with an MPSC channel, how do you I guess we would have to keep the receiver around and hand it off unless it is simply given a sender. Oh, I kind of like that idea. We could give it a sender on construction, and it never has to be concerned about the receiver. This is, should it be bounded? Okay. So now we have one of those. So with our telemetry event, we need in our, where's our constructor for this thing? That's here. New database sync. Our sync manager needs one of these as well. Let's add one of those. There's our sync manager. This would simply be a copy of the other sender. Self.telemetryevents.clone. But where do you get yours? Sync manager. New. Here we go. We have shutdown or connection provider. Where do we put it? Is it the third one or the fourth one? This could be generic as well. Basically, it just needs to be some sort of stream that implements that. Okay. That's going to break a couple of other places. Yep. Now we need one more thing for telemetry events. We'll leave that as a warning. Type telemetry event is private. I understand. Okay. Telemetry event. Hub crate, maybe. Or let's just move that somewhere else. Sure, lib. After error, maybe. Sure, here. Okay. Now we're almost to the point where our test code can have one of these and receive the event. That will really help us know exactly when this has been written to disk, because we can emit a telemetry event saying we've processed a transaction or n number of pages have been written. Very nice. As I'm feeling a little lazy at the moment, I'm going to just copy that other line wherever it went. Here. There's our telemetry sender. We need to remember our receiver. Telemetry events is telemetry RX. And if you would please create the field, thank you. All right. So now that we have the event system in place, what do we expect to see that a DB transaction has been written? I think that's what we're looking for. So in write DB transaction, Void Olgo, thank you for the follow. And Mars06, thank you. Okay, so we have these. This is just a validation. It's not actually writing it. Check some matches. Okay, we validate it. Everything will be okay before we write. Then we write the transaction to disk. Do we not have a self here? We don't. Yes, we're inside of a task. We do not move those in. We'll clone that, pass it through. Now, do we want that evented here or inside? I think I like the idea of it being inside. I do like the idea of being able to log this information but also to event on it. So you can see very clearly when an error happens in the system without having to look at logs, right? I want to see a graph, see a blip on the graph that says enemy incoming, and then go look at the logs. So let's have that here. We should have a type for this. Telemetry event sender. Oops. There we go. And let's put that at the top level. So we can change it more easily. This does not need to be pub anymore. It's at the top level. Now we have our telemetry events. It's unused. Let's make the test work first. Send. Let's say transaction written. Something like that. Generate variant. I think that most of these will not need additional data. We're just saying something happened, and we shouldn't need a lot of context around it. This might change over time. We'll see. Let's go back to DB, go to our test. Oh, wait, we still have errors here. Use of moved value. Oh, no. Telemetry event does not implement copy. Is it saying that? Oh, this should just be a reference. We don't want to send it in. It should be a reference to that. It shouldn't have ownership. We were passing ownership in. Transaction, fine. All right, so data plane. Everything's written. Let's go back to DB, go to our test. Now, at this point, we want to wait for a certain event. TC dot assert assert transaction written event. Maybe something like that. Let's go make one of these. Where's our context? Here's our context. Okay, there's rough outline. TC dot. Now we have our receiver. What did we call it? We construct this thing. Where is it? Telemetry events. Okay. Oh, that should just be self. That's why. Self telemetry events done next. Looks good. Except for next. What is it? Is it on unbounded receiver? Oh, it's receive, isn't it? Same. Oh, they have a receive many now. Interesting. Nice. Okay. Oh, that returns an option. Let's say we could at the moment. No, I'm not going to do a boxed error at the moment. I'll let my future self handle that one because I'm coming up on time. Okay. So we receive an event. Maybe we should just get the next telemetry event. I kind of like this here because I could hide the implementation from the test code. Okay. Cannot be applied to. All right, now it's happy. Does the test pass? Basement 199, thank you for the follow. So we have AA. But we didn't receive. Result may be. What? Don't we just unwrap the event? Okay. Oh, this isn't written. Let's try again. Yeah, that gets me occasionally. Test isn't working. What's going wrong? Oh, you forgot to write the file to disk. And the test passes. Oh, lovely. Nice. Okay, I like this new mechanism. I need to go through and add a number of other events and clean up some of the other tests. I'll probably do that off cam this evening. But I like the mechanism. And these events are going to be useful for production. Using them for test means that they're working too. I like the idea of testing the metric system as well. You know, is a centimeter a hundredth of a meter? I'm kidding. Um, sorry, I fell into like dad joke mode. Speaking of dad jokes, anybody got any good ones? Let's see. What do you call a lost resistor? Ohmless. But all right, that's a good one. I got hit in the head with a can of soda yesterday. Luckily for me, it was a soft drink. I do like the little fake audience laugh, little groans. Oh, yeah. Right? Dressed up as a UDP packet for Halloween. I don't think anyone got it, but I couldn't tell. Hmm, that's a little soft. And where's Cap hasn't been? I see his jokes here. Did you hear about the Pillsbury Doughboy? He died of a yeast infection. All right, thank you. Thank you very much. I will be here all next week, possibly this weekend too. Kind of depends. So, let's find somebody to raid. Any suggestions? Let's see, same category, Rust. No. Okay. Hold on. Sorting. Oh, that's a great idea. All right, y'all. We're gonna kick off that raid. Yeah, y'all take care. Thank you for hanging out. Have a wonderful weekend. I sincerely mean that. Stay warm. Till next time, y'all. Bye bye.